So let us now find out the perimeter of the semicircle with center C. This is half of 2 pi r. Okay, so this is nothing but pi r. But the question is, what is the radius here? The radius here is this part, cm. Okay, or you can also say, if you call this point as q, you can also say cq is also the radius. So either you can write mc or cq, both are the radii. So let me write mc here. Okay, and what is the length of mc given? What is the radius of this semicircle with center c? It is given to be as 2 centimeters. So this is 2 pi. Okay, so perimeter of the semicircle. Next, what we want to find out here is perimeter of this semicircle with center B, this one. Okay, with center B. Again, this is half of 2 pi r, pi r, and but then this time, what is the radius here? The radius here is bm, pi into bm. And what is the radius of the semicircle with center B? Out here, if you see, the radius of the semicircle with center B is given to be 3 centimeter. So this is 3 pi. Perimeter of the semicircle. This time we are talking about which semicircle? Can anyone tell me which semicircle we are talking about? We are talking about the semicircle with center A. We are talking about this part. We are talking about this part. Okay. So with semicircle with center A is equal to half 2 pi r is equal to pi r. But this time the radius here is, what is r? Radius here is AQ. Or if you call this point as P, you can say AP also. AQ. And what is the radius given here of the circle with center as A? It is given to be 5 centimeters. So this is becomes 5 pi. Okay, so all the boundaries we have calculated, length of all the boundaries. We have calculated this boundary, we have calculated this boundary, and we have calculated this boundary. So therefore, what should be the perimeter? Therefore, perimeter of the shaded region is the sum of all the lengths. What are the lengths? 2 pi, 3 pi, and 5 pi. So this is 10 pi. And what is the value of pi that they have asked you to take? 3.14. So now we put the value of pi. 10 into 3.14, which comes out to be 31.4 centimeters. Okay. So this was all about the perimeter. The next part of the question says find out the area also of the shaded region. Okay. So we now proceed to find out the area. But what does the area consist of? If you see in the figure, the area consists of uh, this region here. Okay. This green region, that is area of the semicircle with center C. Also, the area consists of this shaded region, this one, But what is the area of this green shaded region? The area of this green shaded region is area of the semicircle with center A, right? Minus the area of the semicircle with center B. Okay, so that is what the area is. So let's see how to find out the area. So we first find out the area of the semicircle with center C. Area of the semicircle with center C is pi r square. And what is the radius here? The radius here is again CQ. So pi CQ square. And what is the radius here given? The area of the semicircle with center C is 2 centimeter given. So let us put the value pi into 2 square. So you get 4 pi. The area of the semicircle with center C is 4 pi. We'll put the value of pi later. As I told you in the beginning also that whenever you're doing problem on circles, don't be in a hurry to put the value of pi. You can put the value of pi later on also. After your addition, subtraction, multiplication, you can put the value of pi later. Most of the time it will benefit you. Next, what is the area of the shaded region that is here, that is apart from this semicircle? Area of the shaded region within the semicircle, not the semicircle, but within the semicircle with center A. Is area of the semicircle with center A minus area of the semicircle
नहीं सर तो बोले कि मिड पॉइंट थ्योरम
with center B. So area of the semicircle with center A is pi. What is the radius here? AQ. Pi r square, pi AQ square minus pi. And what is the area of the semicircle with center B? It is pi into radius square. Radius here is with center B. Radius here is PB,
पीएम
not PM. PM is the diameter. It is PB pi. And this time, what is the radius of the circle with center A? It is given to be 5 centimeters. So put the value here, pi into 5 square minus pi PB. What is the radius of the semicircle with center B? It is 3 centimeter. So put the value here, pi into 3 square. So this becomes 25 pi minus 9 pi, becomes 16 pi. Therefore, area of area of this part here is how much? We have found? We have found out this to be 16 pi. And what is the area of this within this semicircle? We have found out this to be 4 pi. So therefore, what is the total area? It is the sum of the two, 16 pi plus 4 pi, which is 20 pi. Now you can put the value of pi. 20 into 3.14 142, right? So only 3.14. Okay, it's 3.14. So this is 2 into 10 into 3.14, which is 2 into 31.4. So this is 62.8 centimeter square. Okay. So this was this problem here. We now move on to the next problem, number 12. Now, number 12. Can anyone tell me what should be the area of the shaded region for number 12? Just by looking at it, can you tell me what should be the area of the shaded region? Can anyone tell me?
Sir, area of the semicircle AB,
Semicircle
AC,
AB.
sir,
Semicircle
AC.
with diameter AC. Okay.
Yes, sir. And minus, no, area of minus the area of quadrant BC.
Area of the semicircle with diameter AC minus area of the quadrant BC. Are you sure about this?
No, sir.
Let us see. It's a rough sketch of the figure. This length ABC is a right angle triangle. Okay, so this angle is 90 degree. Okay, and AB is 28 centimeters. So this entire length is given to
Sir,
you
I'll
as.
say.
Yes, tell me.
Sir, area of triangle minus the area of quadrant, the small quadrant.
Wrong. So this is 21 centimeter. This length is given. Okay, and yes, and let us call this point as P, as I have called it. Then what happens is, if you see, this PBC becomes a quadrant. PBC. Okay, PBC becomes a quadrant of a circle. Okay. Now the question is, which one is the shaded region? Now see, shaded region is the this problem is a little confusing actually, but try to see the whole figure. If you see the whole figure, the area of, if you calculate the area of the whole figure means this entire part. What is the area of this whole figure? Can anyone tell me what is the area of this whole figure? This blue shaded region, the whole figure.
Sir,
Sir,
area
area
of
of
the
the semicircle and
triangle
area of
plus
quadrant.
area of the
Not
quadrant.
quadrant. Area of the triangle plus area of the semicircle.
Yes, yes, sir.
Not quadrant,
Okay.
right? So area of the entire figure is area of this triangle ABC, the right angle triangle that you can see, plus the area of the semicircle with AC as diameter. Okay. So let us find out the area first. Then I will show you how to analyze the figure. So area of the complete figure is equal to area of the triangle ABC plus area of the semicircle with diameter EC. But do we know the diameter of this semicircle? We don't know. But what we see is that this diameter EC is also the hypotenuse of this right angle triangle, right? ABC. So we can find out the hypotenuse by Pythagoras theorem. So let us proceed to find out the hypotenuse by Pythagoras theorem. So we have in triangle ABC, AC square is equal to AB square plus BC square. So now you put the values here, 28 square. AB's length is given to you as 28. BC is given to you as 21. So this is 784 plus 441. This will give you 1285. So therefore, what is EC? The length of the diameter, square root of 1285, which comes out to be 35 centimeter. So the diameter of this semicircle AC is 35 centimeters. Okay, so what should be the radius?
So it will be 1225.
Oh, 1225. So what should be the radius? Radius should be half of the diameter, 35 by 2. Okay, so let us calculate here. Now, area of the complete figure is area of the triangle ABC, as I told you, plus area of the semicircle with diameter AC. What is the area of this triangle? Half base into height. What is the base and height here? Half into AB into BC plus. What is the area of the semicircle? Half of 2, half of pi r square. What is r here? Half of pi. What is r here? R is half of the diameter AC by 2. Okay. So this is half into 28 into 21 plus half into pi into EC is 35. We have calculated 35 by square. Okay. So this is cancel. So area of this triangle comes out to be 294, and this one is put the value of pi. What all cancel here? Cancels. Okay. This comes out to be 294 plus if you multiply this 1925 by 4. If we take the LCM, 294 into 4 is 1176 plus 1925. 3101 divided by 4. Leave it as a fraction because we need to calculate with this also. We need to work with this number. So we have found out the area of this complete figure, the blue, the one that I have shaded in blue, the complete figure, to be 3101 divided by 4 centimeter square. Okay. Now the question is, what should be the area of the shaded region? If you see very carefully, the area of the shaded region from the blue region, that is from the area of the entire figure, if you exclude the area of this quadrant, will you get the area of the shaded region? Just check.
Yes, sir.
If you exclude from the blue region, if you exclude the red region, will you get the area of the shaded region in the figure?
Yes,
Yes.
sir.
You will get. Fine. That means we have found out the area of the region that is shaded in blue. Now if we find out the area of the this quadrant shaded in red, and if we subtract, then we'll get the area of the shaded region, right? So let us proceed to find out the area of that quadrant. area of the quadrant, area of the quadrant with center what? B is equal to 1/4 of pi, and this time what is the radius? Can anyone tell me from the figure what is the radius of this quadrant?
Sir, BC.
BC, exactly. Pi into BC square. So 1/4 into, put the value of pi, 22/7. I put it earlier also. Nothing is given, so you can put 22. No problem. 22/7 and into BC here is 21. 21 square. Okay, so 1/4 into 22/7 into 21 into 21. Cancel this. So what you'll ultimately get is 1386 divided by 4 centimeters square. This is the area of the quadrant. Hence, what is the area of the shaded region? It is area of the complete figure minus area of the quadrant with center B. So area of the complete figure we have found out to be 3101/4, and area of this quadrant we just found out to be 1386/4. So now if you subtract, you will get 3101 minus 1386 divided by 4, which is 1715. Divided by 4. Now you can convert this to a decimal form. Comes out to be 428.75 centimeters. Okay, so that is what this problem is all about. Moving on to the next question. In fact, this question here is something to understand here in this next question. What is the hexagon? If you remember in the last class, I told you that hexagon is nothing but a polygon
6 sides.
having
Sir,
6 sides.
polygon with 6 sides.
And this is a regular hexagon here that we are talking about. Okay. And within this regular hexagon, they have inscribed a circle. My figure is not too accurate, but the idea would be fine. This is a circle that is inscribed in a regular hexagon. Okay. This is the center. The question is, find out the circumference of this circle, inscribed circle, and the area of the inscribed circle. Okay. And the side of this regular hexagon is 2√3. So if I call this hexagon this, and each side is given to you here as 2√3 centimeters. Each side is 2√3. Okay. Regular means all sides equal. Now the first question, circumference of the circle. For circumference or for area of any circle, you need the radius of the circle. And what should be the radius here? If you draw a perpendicular from this center of this circle to this point, okay, say the center is O here. If I draw a perpendicular from O to this point, then this becomes your 90 degree, because you know that in fact we have in this line AB actually is the tangent to this circle. Okay, so that is why, so you know that radius is perpendicular to the tangent. So therefore, this has to be 90 degree. Even if you're drawing any straight line from O to this point M here, this has to be 90 degrees because radius is perpendicular to the tangent. AB is a tangent. Anyway, but we draw a perpendicular from O and we call the foot of the perpendicular as M. Okay, and what we do is we join OB also. So OM actually becomes your radius. This is your radius of the circle, right? OM becomes your radius of the circle. We are going to find out the length of this radius. Okay. Um, so, but the first thing to note here is the property of a hexagon. Very important property. The property of a hexagon, this one is the property. A hexagon consists of 6 equilateral triangles. If we join 6 equilateral triangles, then it will become a hexagon. If you see in the figure that I have drawn here, see there are 6 triangles here. 1, 2, 3, 4, 5, 6. Okay, so the hexagon consists of 6 equilateral triangles. So that means if I join OA also, this is actually OAB is an equilateral triangle. And what are the sides of this equilateral triangle? This is 2 root 3. This also has to be 2 root 3. This also has to be 2 root 3. Right? So now, can we find the radius OM? Yes, we can find out. How can we find out?
Yes, sir.
See, MB here is half of AB, which is half into 2 root 3, which is simply root 3 centimeters. Okay. So, and OB we already know. OB is the same as AB because OAB is an equilateral triangle, which is equal to 2 root 3. Now, if you consider the right angle triangle OMB, OB is the hypotenuse. So OB square is equal to OM square plus MB square. That means we need to find out OM. So what is OM square? OM square is OB square minus MB square. And OB is 2 root 3 and MB is 3. So this gives you 2 square into root 3 square minus root 3 square is 3. So this gives you 4 into 3 minus 3, which is 12 minus 3, which comes out to be 9. So therefore, what is OB? Square root of 9, which is 3 centimeter. So we have found out the radius of this circle. So now can we find out the circumference and area? Yes. So what is the circumference? 2 pi into OM.
Pi.
That is 2 pi into 3, which is 6 pi. Okay, now you can put the value of pi or leave it the answer as pi also. No problem. And what is the area? Pi r square. Pi into 3 square. 9 pi. So circumference is 6 pi and area is 9 pi. Okay. So stop here for today.